All right. Good morning, everybody. So we are on the topic of septic tanks. Kind of ran out of time last week, but we wanted to go through just finish discussing about septics. Did everybody get the email about drying up a septic system? Yeah, Daniel get his. JP, Jacob. Justin Alcos. Cupono, you enjoy yours, Cupono? Oh, Mike. Ew, what are you going beach? LeBron. So the reason why we had you guys kind of draw it up is just to kind of it's just an exercise for you guys to like know how a system works or what it looks like, and it was just for your own your own interpretation of a septic tank. I mean, it looked like everybody had the same thing going, which is good. And um the reason for it is it's easier for you to explain if you know what you're talking about to customers. I mean, you could draw it out for them, and you'd be able to mentally explain it to customers to help educate them in the septic system. So what we're gonna do today is Ken's gonna run you guys through some questions and how we're gonna answer these questions, and we're gonna put it in the chat. So as Ken asks the questions, we'll give you guys like maybe a minute to kind of write it up in the chat. It's more of like we were gonna break out into rooms, but I think we're just gonna stay in one big room and we'll all discuss here. So here we go, Ken. The floor is yours.
I'll just start calling people. Maybe that'd be easier.
Yeah.
Okay. Mr. Corpuz, in a rural setting, when entering a home and the call is whole house backing up, what should be the first question you ask your customer?
With the main line backing up?
Let's just say I'm the customer. My complaint is when I flush my toilet, water comes up in my shower. And you're the technician on site, but we are now in a rural area.
If there are any cleanouts outside, any access points that I can get to see, because with other cleanouts around different areas, I can see how far the cloud could be or what point to get it best from.
Okay. Let's stay on with me. So let's just say we find out that I have a end of the line cleanout, and when you flush the toilet, sewage is pouring out of that end of the line cleanout. What should be your next question?
If they have a septic system or if they're tied into the city.
So important. So his question was, do you have a septic system? And we talked about this last week, the importance of it. And let's ask Jacob Uphold. Jacob, why is it important to know if the customer has a septic system, cesspool, or tied into the county?
If you got a mainline stoppage and the tank is full, cesspool is full, tank is septic is full, you can cable for days. You ain't gonna clear it. You go pop open the cover, see if it's full, and go from there.
Okay. So Brandon R. Let's say we've determined that the tank is full, or they have a septic system, but we can't find the cover. What is our next step?
We can camera locate, get our camera at least to hopefully to the end of the line, and then basically just camera locate that.
So what are we looking for when that's happening? What are we telling our customers? So are we finding the cover?
No, we're usually finding the inlet. So
Okay.
I usually go 3 or 4 feet out from that in a circle.
Are you guys following so far? If you guys have your cameras off, turn it on, please. That way we get 100% participation. I'll give you guys a couple seconds to turn on. So I'm going to try and walk us through the full service of a rural area call. So we've determined that the customer has a septic system. We've determined that maybe potentially the septic system is full. Let's say we've determined that the cover is buried. And now the last question was, how do we deal with finding this cover now? So Brandon's suggestion was we do a camera locate. So let's just say I'm the customer. Okay, I approve the camera locate. We get to where the inlet of the septic system is. So let's talk to Mark Dolopak. So we find the inlet. So what do we do to get to the cover?
Pretty much we gotta dig it up, try and locate the cover and get it exposed.
So if we're on a septic system, how many covers usually are there?
2.
And if it's a cesspool?
1 mostly.
So you guys understand the difference, right, between a cesspool and a septic system? Cesspool is a single tank that holds water and solids. The septic system is the holding tank that goes through a distribution box, then exits out through the leach field. So let's say the house is newer and we're dealing with a septic system. So we've exposed, or we got the authorization to deal with the cover. So we expose 2 covers. Let's say the septic tank is full. Are we certain that the problem is the septic tank? Let's talk to Mr. Kapoy.
No, because most times your septic tank will be full with liquid. I would say you would have to find your distribution box and go from there.
Good answer. So there's a third problem, right? So now we've uncovered the tank covers, and I'll guarantee if the tank covers are buried, the distribution box is going to be buried. The problem with that is the box is always lower than the tank because it's the lowest point. It's where the effluent or water leaches out into the leach field. So if you can imagine, let's just say you've located the tank and you're uncovering the tank covers and you're about 2 feet deep. Well, the size of a standard, let's say 1,000-gallon tank, Daniel, what would you say the height from bottom to top of the tank is?
I've seen them like 15, 20 feet tall, septic tanks.
So let's just say on an average home, a 4-bedroom home. You're thinking long. I'm talking, from base to height of the cover.
Well, maybe like 10 feet.
Okay, that's humongous. So let's say on average, I would say they're about about 4 feet. Okay, so let's say your cover was 2 feet deep. So how deep, Sam, would your distribution box be? You got to turn on your mic. Yeah. So now you got to start figuring out what kind of equipment, or are you going to go hand dig 6 feet down to go look for this distribution box, right? So go back to the side, the cover. Should you be hand digging to expose where that cover is? If the distribution box isn't exposed? Josh says yes. Who are you sending to that job? We're gonna send Chris. You know what I'm saying? So what I'm trying to do is paint a picture for you guys on how to approach these jobs and work with your customer and understand, because these are all questions. So if I'm the customer, I'm gonna ask you like, fuck, why you gotta get an excavator on this job? Why does it cost so much? Blah. So now you can intelligently explain to them, right, step by step. Hey, if the cover is 2 feet deep, you know, that's 2 feet of material that we gotta expose in 2 areas. Then your distribution box that's not exposed is potentially 6 feet deep. We gotta expose that section. And if the distribution box isn't within, let's just say 2 feet of the cover, and I'm hand digging, that's a lot of digging. You know how much material comes out of the ground when you're dealing with a 6 foot or a 5 foot deep hole? It's a lot of material. You do not want to be digging that by hand. I don't care if it's sand, it doesn't even matter. You know, I think for me, my thought is if something is more than 2 feet deep, you should probably get a mini excavator on site. Because unless you know for a fact exactly where it is and how much of a footage you're dealing with on a repair, you know, a hand dig is fine for a targeted repair. But the moment the job goes beyond the scope, it doesn't allow you to expose and expand on the job. With a machine on site, that changes the whole dynamic of the job and the call. So now that we're at the distribution box and we're 6 feet deep, we're exposing that. Let's just say we have the box open and water is not entering the distribution box. JP, what is the next step?
The next step, you've got to clear the line between the tank. Well, the tank is full.
Tank is full. Tank is always full, right?
Well, yeah.
But we don't know if the mantle, which is the solids that are on the top of the tank, is the problem, or and if it is a problem, what's probably happening, you explain what's happening.
Well, something has blocked the pipe in between the tank and the distribution box. So the exit.
So what would the repair be? What would the I would say recommendation at that time be?
Is there usually, I don't know too much about septics overall, is there usually a clean out for the exit line?
So you know what a santee is, right?
Yeah.
So you have a santee, let's just say on the inlet and the outlet. And Josh's explanation last week in the graph, I don't know if you can try pull it up, Josh. Maybe just throw something up on a tank just so we can get a visual. A lot of times what happens is the solids has overcome the exit. And so the problem is now you're not leaching out the liquids. The customer has waited too long to pump the tank. And so now potentially the problem could be, it could just be a full tank. And, you know, the call at that moment would be to call septic, somebody to come out and pump the tank. So you see on the diagram, so look into the, yeah. So you see how, because, you know, water seeks its level, right? So the whole objective is water to raise from the pipe on the bottom on the left side. Josh, I put your pointer on that thing. Yeah. And where do you not want to see it go over? There, you see that section? Yeah. So once the water or solids raises to that point, you already know you have a problem, because again, just remember this term: water seeks its level, right? So if the mantle or the solids is above that point, you already know the exiting pipe is consumed with solid, and therefore no more liquid can leach out. You guys all follow me? You guys, anybody have a question right now? You guys have a question, please ask. Connie, you got a question? Something that, no? Okay.
Do you guys understand what Ken's saying? Yeah. So when this is your inlet to your tank, these are the outlets. So whenever you see the water at this level here on your septic, you see the pool of water just sitting right at the base of that Santee. You know that it's not full yet. It's still got, once it rises above the top of this Santee, you're dealing with or you can't see the baffle T. You're dealing with a full septic. And then at the end here, so what if you look at these are all lower than the inlet. They're brought in lower on a septic system. So this is your it comes in layers. Sorry, hold on. Oh, what the heck is that?
I might have confused you guys. I was looking at the left one as the exit, and that's my fault. So Josh, what Josh is saying is correct. The inlet on the left, exit on the right. You continue, Josh. Sorry.
So you have a scum layer, effluent layer, and a sludge layer. The scum layer is your grease, fats, oils, and stuff. This middle area right here is just supposed to be just straight liquid, and then your solids and sludge sink down to the bottom. So if that water level is above your Santee, it's full. And all these Santees on your right, which is the exit side, which goes to this effluent tank and then leaches out to your distribution box and goes out to your leach field. So if you could see this T, you're not dealing with a full septic. If you can't see it, you're dealing with. I know a lot of guys get confused on, oh, your septic's full, because they see the water levels 2 feet from the top of from the bottom of the cover. It's not necessarily full, and we get a lot of kickbacks from customers saying, I pumped my septic and my line's still backed up. So it's very important that you guys understand that just because you see water sitting at the bottom of this Santee here does not mean that it's full. This Santee here has to be fully submerged, or water coming through this cover to know that it's full.
I just worked on one, Josh, and it didn't have baffles and pipes like we see. It was just a hole at the first. It had 3 chambers going from the first to the second. There was a hole on the bottom, and then on the second chamber to the third, there was a hole on the top, like it was naturally separating. Like it. I don't know if that makes any sense. But
does anyone know why they put baffle T's in there? So the reason why they use Santees, or it's a breaking point for water entering the septic tank. It doesn't cause, if this was just an open pipe, what's going to happen is it's just going to pour on in here, and it's going to break up the sediment or the layers that you have in here. So this is more like a splash guard from causing all the sewage and everything entering the tank from, just mixing up the whole time. So this kind of keeps it settled as it enters the tank. The solids are going to hit the back wall on here instead of hitting this, grease layer or the effluent layer. And what happens is it sometimes it'll sit here, but, eventually it'll sink down, and everything will go to its place. So that's the reason why they use baffle T's or Santees in the septic and the release of the septic, so that when water's rushing through here, it's not mixing everything up in the tank and causing disruption to what the septic is made to do, which is separate and release.
And a lot of them have chambers. So you see the chamber in the middle. So what that does is it gives you stages too. So if the first stage is full, that's something that can be concerned. But if your second stage is full, and going to what we're discussing, we've determined that the distribution box is not getting liquid in it, and your second stage is full, we got problems, right? So let's just say now we've called the septic guys, they come out, they pump the tank. Tank is empty of solids, but you're still not getting effluent or liquid flowing from the exit into the distribution box. Preston, what would you say is the problem? You got to unmute.
That is sign language.
The
Jason
line
knows.
from
Jason knows.
the exit line is, there's a stoppage.
Yeah, I mean, what would you do? How would you deal with it?
Hydrojet up the D box.
So we've exposed the distribution box. We know where it is. You're jetting backwards from distribution box or from the baffle T into the distribution box to kind of clear that exit.
Yeah.
You guys understand that? So what would the next step be? Let's say now you got flow, and where should that flow end up after the distribution box? John.
Get on mute, Jun.
Ground.
Sorry, can you ask that question again?
So the question is, so we've determined we had a stoppage. The customer had allowed us to clear the stoppage out of the box after being pumped from that distribution box. We have a jetter on site. We've cleared the stoppage, and we're wondering now, after the distribution box, where does the water flow to? Where does it end up? It went from the tank to the distribution box. Now it's going where?
To the leach field?
Yes. Yeah. And now we've completed the system. So I have a question for, let me see. Jonah, what kind of products now should you recommend to the customer? What can you recommend to the customer as far as any kind of maintenance or any kind of service for future work or maintenance on his septic system that may help him with this problem not from reoccurring in the future?
Would a live enzyme help?
I would say an enzyme would help, but probably a live bacteria would be better.
Okay.
And that's a great suggestion. So, on average, Josh, what is the average amount of time on a basic, let's just say 3-4 bedroom household, if I have a septic system? How often should I be pumping that tank?
So the rule is behind that is they want you servicing or pumping your tank every 3 to 5 years.
And I'm going to say it's based on consumption or the amount of consumption that's happening. So if you have a basic 4-bedroom home, and let's just say, you have, mom and dad and, your 3 kids. So, you have a household of 5. That's one thing versus, you have families now living in a single a home like that, and you start adding to the equation. That average is based on an average household. So if you're there and you're noticing, you're like, wow, man, there's a lot of people that live here, and you got to start playing detective and start asking a lot of questions. So if the average is, let's say, 3 to 5 years, and now instead of having 5 people there, you have 10 people there. I mean, you could do the math, on how often that tank should be pumped out, and those are the things that you should educate your customer with. The other thing is, I don't know if, how often are you guys dealing with BioChoice, Bennett, on Oahu? You guys still have BioChoice there, yeah?
Yes.
Are you guys recommending BioChoice when dealing with like kitchen sink stoppages, grease, and septic systems?
Yes.
Yeah, good. So that is a live bacteria, Jonah, but it's not an enzyme. It's 2 different things. An enzyme will reform, and Connie can probably, there you go, Justin A just showed it. It'll reform later on down the line. Connie, you want to give a little bit of information regarding BioChoice and how it kind of and the difference between BioChoice versus an enzyme?
Yeah.
So Bio One or Bio Choice is a product that has 100% bacteria. It doesn't require enzymes to break down fats, oils, or grease or solids. And that's what an enzyme does. We all have enzymes in our body, but it's a component that will actually break down things so that bacteria can consume them. The bacteria that's in Bio One does not require that because it's manufactured to do so on its own. So the challenge with if you just get an enzyme product, because they do sell just enzyme products, is it does exactly that. It'll break it down, but if there's nothing there like live bacteria to consume it, then what happens is after a while, those items will come back together and reform further down the line. And in municipals, that's a big problem. So that's why they don't endorse products that are enzyme only. But for some reason, they're still sold. Now, the other thing is that, and I wanted to ask this question for Josh and Ken, and I don't know if we have the answer. I know that the idea is 3 to 5 years to pump a septic system, but I would assume that's a septic system that hasn't been treated with a bio product. And if you can treat or suggest that using Bio One, Bio Choice as a product that they would use, they probably could eliminate the need for pumping out their system as often as 3 to 5 years. So I believe 3 to 5 years is an untreated system, something where people kind of ignore it, and then they have to pay $500 to $600. I don't know what it is now. It might be more, just due to the cost of things. It might be $700, $800. I don't know. It's a good question to ask your customer. How often? When was the last time they pumped it, and what was the cost? But a treated system, I believe, shouldn't have to be pumped ever.
I would say something regarding that. So if you're trying to educate your customer, the worst thing that could happen besides their line backing up would be their leach field failing. And a leach field will fail because they're constantly allowing their tank to remain full. And so what happens is a lot of the solids will eventually keep passing by until it just backs up and plugs up 100%. And then there's nowhere for it to go. So then you gotta wonder, like, okay, what's happening during the time when it's all drying out? Well, all the solids dry out. I mean, has anybody here dealt with, like toilet paper or some solid that really it's not like a broken line, grease in a line that's hardened over time because it's dried out? I mean, raise your hand. Pretty much everybody's dealt with it one time or another. There's times where you just have to dig it up because there's nothing you can do. And ultimately that's the worst case scenario. So the ultimate goal is to protect the leach field, the distribution box and leach field. So BioChoice in this environment, it becomes really, really important. I don't know, and kind of, I don't think I would ever not recommend them not pumping it, but as a pump truck guy, or, what they can start doing, and if the person is there and he's somewhat, educated now on his septic system, he can be watching what's happening. Let's just say, to prevent this nightmare that just happened, I'm going to make sure, okay, I call the pump truck at least every 2 years for now in the beginning, just to see where we're at. So let's say he calls the pump truck and it's year 2 after the disaster, and they open the covers and find, oh shit, I've been using BioChoice, and really it's all liquid in my tank. The guy pumped it down, there's no big deal. Well, now you can make an educated guess on how long you can wait the next time. Maybe you wait 3 years and you still experience the same thing. Well, now you know your BioChoice is working on a regular basis versus, hey, you know what, use this product, you don't ever have to worry about it. I wouldn't recommend it quite that way. I would have them be educated and stage it, so they understand what's happening with their system. And to me, it's important that we understand beginning to end. And, Josh had you guys drop a design, and it's not, to me, that's for you to educate your customer when walking up on these jobs, because there's nothing like a customer who knows nothing about plumbing or septics to now understand how stage 1, stage 2, stage 3 works, and how it should work in the future going down the road. To me, that knowledge is power. That helps you guys sell, the step-by-step that needs to happen. And it is a process, because you can kind of see what we just went through. on let's just say a worst case scenario septic system failure. You know, how many steps did we go through? You know, we had the service call. You know, then we had to inform the customer, oh, you have a septic system. Okay, we figured that out. Oh, we can't find your cover. Your tank may be full. I mean, now you're on step 3. Okay, we got to call a pump truck. You know, step 5. Oh shit, your exit is still okay. Step 6. At what point are they looking at you that you don't know what the hell you're talking about? You know, maybe they may be thinking like, oh, why couldn't you just deal with that exit line in the beginning? But if you draw it out and explain to them how everything works, and explain to them all these steps may take place. You may have step 1, you may have step 2. It may be just a full tank. We drain it and you may be good, you may not. You know, Josh said it last week. Once that tank is pumped, you as the technician may want to be back on site to make sure you can take care of the customer in the event that line is backed up. And if it's been backed up for a while, it will probably be backed up. Their inlet will probably be backed up with toilet paper and waste. The exit could be still be possibly backed up, and you want to make sure you're taking care of all that. But those are all chargeable calls. You know, so understand your value. You guys all have the right equipment. You guys all have access to jetters, or somebody within the company does. You guys should all have snakes. And if it gets confusing, at least now you're somewhat educated on step 1, step 2, products that we have in the field, how to address the situation. The only difference is if you get to an older neighborhood and they have a cesspool versus a septic tank. You know, so my question would be, what happens if you get to the same situation? Let's just say whole house backup, can't find the cover. We sold the customer the dig. We're going to expose the cover. Let me see, Mr. Barnett, what are we looking for when we're looking for a cover on a cesspool?
When I'm looking for the cover,
Yeah, because it's different than a septic tank, that's for sure.
oh yeah, for sure. Hopefully they have a riser and a access to the top of the lid.
Let's say there is none.
Let's say there is.
And your inlet was, let's say 3 feet deep.
Do I have a locator and a camera?
You've already located the inlet. Inlet's 3 feet deep.
I'm pretty much going almost right above the inlet is where I'm going to start digging, because you'll at least find the top of the lid, and then you can go from there. That's kind of how I would figure out trying to find the access to that cesspool.
So a lot of times what they did in the past was they put a concrete slab, and a lot of times just right over a dirt hole. Sometimes it's brick layered. It just really depends on how they design the structure beneath it. But
I've gotten lucky too. You know, if you locate the end of the pipe.
Yep.
And then you can kind of imagine where the cesspool would be and kind of where the center of it would be, and you'd think the pipe would go into the tank about 1 foot or so, and maybe it's a 4 foot or a 5 foot hole. Maybe start digging 2 feet beyond the end of your pipe.
Yeah.
I don't know.
There's times when it's in the center. There's times when it's in the corner. There's times when there is no cover. We've seen them all. I've exposed a whole cover, top of the septic system, cesspool, with no cover. And then what we ended up doing was calling a coring company to come out and core a 10-inch hole. And then we create the access. You know, so these are all the other things that you guys got to be aware of. So like, again, let's just say, oh, okay, let's get the machine out here. We sold them on a dig job. We're going to put a riser on. You scrape that whole damn cover. Let's say it's 10 by 10 and find there's no damn cover. So how do you address that? You know, I mean, you got to now have an idea, because we're still trying to help this customer. So we did one at First Hawaiian Bank up in Pukalani. And it was exactly that. So called in the coring company, they came in, they cored a hole, called in the pump truck comes in, they pump down the cesspool. But here's the thing with cesspools, right? So why is your cesspool full? And how do you deal with that? Because if your cesspool is constantly filling up, where is it leaching out? So let's say, Justin, Justin Alcos. What would you say the answer to that would be? Where is the water going, or where is it not going? What's happening, and what's the cure?
And that's when we can't find a cover at all.
Well, let's just say we found the cover, we have it pumped, but now I'm the customer. I'm like, well, where's the water supposed to go? And why did it fill up? Let's just say it was a combination of liquid and solids in the tank, not just solid.
And where it's supposed to go. So usually I came across one where a cesspool was filled, but it's still tied into the city. They made a overflow.
Let's say you're in a rural area and it's not tied in. So on a cesspool, unlike a septic system, it leaches out into the walls of the tank. You know, so the theory is the tank holds the solids, yeah, and then the liquid should leach out into the ground. No different. I get a cup of water, I drop it on, I pour it on the ground, it disappears, right? The ground takes it. It rains in your yard, you know, your yard doesn't fill up with water, it ends up just draining into the ground. It's the same theory. So the tank holds solid, you know, or the hole in the ground holds the solid. The dirt around it should allow the liquid to escape, but let's just say it's not escaping anymore. You know, that is a whole nother problem, right? So again, biochoice, you know, is it a possibility that there's a scum layer now that's clogging up, you know, any kind of perforation that may, or percolation that may have, or have the potential to occur. You know, this is when it gets a little tricky. And if the ground is, and we'll use the word saturated, or percolated to the point where, or not percolating to the point where you can no longer get liquid into the ground, the next step would probably be to get engineering involved and maybe install a septic system. You know,
things are going to get heavy duty too in Hawaii. You're not going to be able to sell a home without having a septic system. We need to be able to put those in, huh?
Or have a great referral, you know, and have those guys refer things back, and we can work together with somebody, because it takes a lot of equipment. You know, you can't just have a 303 and be digging this thing. You need something that can get down like 10 feet. You know, these tanks are huge, you know, and you need, and you need big equipment. What was that?
Has anybody ever tried like aerating it, you know, trying to mix it with Bio-1 and break it down?
Have not, but you know what? Those are great questions. So those are the things that, you know, we can start trying to figure out, because like Justin said, as time goes on, you know, you guys got to have answers to things, you know, and you want answers and solutions that actually work.
Ken, this is Steve. Let me interject for a minute.
Go ahead.
Mr. Burnett, you know, you made a comment that was false about the septic tanks. You can't have cesspools going forward. You have to have septic tanks, one. So just make the terminology correct. And that's phasing out in the next 20 years. So anybody has a cesspool that's failing now, they just need to change it to septic anyway, because they have to. Two, when you're talking about aerating, Justin, the lines, that actually is a normal process for leach fields. And there's equipment and tools made to go in and create that aeration and blow out the perk holes, or the perforation holes in the leach field. So yeah, if you study that a little bit, you'll see that there's solutions. Whether or not you can find somebody to do that, there was a guy on Maui, and he moved to Oahu, that had the equipment that you would take in. You'd have to dig up the D box, and you shoot the pipe that's kind of a tube like a jetter hose into the leach lines, and then they blow them clear again. And of course, you're throwing biomaterial into the leach lines also to rejuvenate the percolation. So just to add to that thing, there's a couple little elements, and it's very, very complicated when it comes to cesspools, percolation test, and conversion to septic tanks and air, and then with no room for septic tanks on normal leach lines, then you have to go to aeration tanks with a whole different process. So, do your reading and pay attention to it, and you'll get to it a lot faster.
Yeah.
Check.
So, what Steve is saying is basically it's important we educate ourselves, right? So this whole process and what we talked about last week, I told Josh, man, it's really important that we understand this, as a technician. And to me, the ease of sale comes from your knowledge towards the customer, right? I mean, when you're comfortable with something, very easy to educate, instruct, and sell the customer. Customers feeding off your confidence. If they're asking questions and you're able to intelligently answer them, how much easier is it to walk them through this process? Like I said, we started with a stoppage. Then you had to go and locate. We didn't have a cover. I mean, you probably gave that customer maybe 5 or 6 quotations before you completed the job. And so very important of an understanding of how to approach these jobs. And then knowing the difference between a septic system and a cesspool. They're two entirely different things. They operate relatively the same, but they are totally different. And knowing that you can't put a cesspool in these days, everything has to be septic because it is its own treatment plant. What Steve talked about is a whole nother step and about aerobic system. And that's a whole different thing. It's a septic system with pumps in it that aerate the bacteria. I think we talked about it a little bit in Josh's class last week. And what does the air do with the bacteria? And I'm going to ask Brandon R.
The air basically kind of like supercharges the bacteria, like it gives it more oxygen, more fuel to kind of stay alive and do its job.
Correct. Yeah. It creates the treatment of the water or waste to happen a lot quicker, and a lot faster. So when it's leaching out into the ground, you have a cleaner effluent that's going into the leach field. They require that a lot of times in areas where you're close to the water table or near the ocean. Steve, you got a thing for that?
Brandon, you're absolutely correct on the air. The difference is that you guys know that there's a vent on a house for sewer systems that let the gases and sewer gases escape. So the reality is that what you're doing by doing the air is you're creating a faster digestive system. It can gas out faster, dissolves faster, becomes cleaner faster, so they can get rid of it in a smaller area faster. So all you're doing with air is you're facilitating the digestive purposes or functions of the bacteria, and it gases out faster. That's basically the essential part of an aerobic system. And they're designed for 2 purposes. 1, for small areas, so they don't have to have as much leach fields, and 2, for higher volume, so they can get rid of the waste faster. And other than that, Brandon, that was pretty good.
Steve, do we have an aerobic system at our Lyco shop?
Yes. I think, Steve, we had Galeal put that in for us, yeah?
Yeah, that's correct. I lost my screen. Am I muted or you hear me?
We can hear you.
Okay, because I don't see any exit full screen view. The hell? Okay, yeah, we have an aerobic there because it's required, not because of the lot size. It's just a CCNR of that subdivision. So that means it's going to have yearly maintenance, and we have electricity going to it and all that good stuff. But it's all designed for a little over 1,000 gallons a day, just to be detailed about it.
Does anyone have any questions regarding conversation? Did anybody get a little lost anywhere, or any questions on how to approach anything, or would like a little bit more information on it? Do you guys think that helped with understanding regarding a septic system and how it flows? And yeah, I mean, educate yourself. It's really basic. There you go. Daniel Capoose got it up there. But that simple drawing can be done right in front of your customer. And I would encourage you, when dealing with them, draw it right in front of them. Step one, okay, this is your tank. This is where it holds water. You have probably 2 chambers. What's happening is chamber one, now you're explaining it to them, and they're now understanding what you're explaining. They'll get the next step, the next step, the next step. That way they're not lost in any of the steps. You know, it's very important you walk them through it. I tell you, that is one of the worst calls sometimes when the technician doesn't properly address the customer, you know, in these situations. So understand the value of your knowledge walking into these rural areas with septic or cesspools. And you guys, it's your responsibility to understand the difference. So, Josh, you have anything?
No, yeah, and so that exercise for you guys drawing it is also to help you, some of you who don't really deal with septic tanks. Now you have a mental picture of what it is, how it works, and you know, I hope we were able to get you guys educated on, you know, that side of the sewer system, which is the septic tanks and the cesspools, and that should close this chapter on septic tanks. And thanks, Steve, for chiming in. It's always nice to get great knowledge like that.
Bennett had a question. Bennett's question is, how much biochoice do you tell the customer to add into a 1,000-gallon tank? Connie, how would you answer that?
Okay, so if it's a residential, I guess 1,000 gallon, I don't know if that's normal residential. If that's normal residential, if you're dealing with a residential situation, the recommendation has been 3 2.5-gallon bottles at the initial stage, and then you want to leave behind either 1/2 gallon, or if you want to leave the 2.5-gallon last one for normal maintenance after that point. And you can get that in either by directly pouring it into the tank itself, or if you want to pour it through the toilet or any other drain line, that's fine as well.
I would recommend going in through the kitchen sink, because now you're dealing with your fats, oils, and greases as well. You know, kitchen line is usually the worst line to deal with. All you guys understand that. We don't need to explain that, but it will eventually get into the tank. What Connie is saying is, on the initial, if they have, let's just say, a failed cesspool, and what you're trying to do is deal with that scum layer. Now that the tank is empty, what you want is live bacteria from the ground of the cesspool to have, you have that environment where you have live bacteria thriving as the water level is rising. So it'll start slowly eating away at the scum layer that's on the exterior on the walls. Yeah. And then you're adding to it monthly. So you have a heavy dose that goes in first, and then you're just keeping the environment alive. So the live bacteria, it dies off. It consumes fats, oils, and greases. That's how it thrives. And then it dies off over time. And so you're constantly just reintroducing it into the system. You know, and what kills it, again, we talked about this, is Clorox and bleaches and detergents. All those things that go into the system will kill off the bacteria. And over time, bacteria just dies. You know, so that's kind of how you deal with that.
They also regenerate, you know, so the bacteria grows as well, you know, but what Ken says is, yeah, there is a killing off based upon our antibacterial soaps and things. So yeah, replenishment is a good practice, especially if you have a cesspool or septic system.
How about versus Ridex? Is Ridex, first of all, I think it's a live bacteria also, right? But everybody seems to know about it who has this kind of system. Why would they go with the bio one?
I think Ridex is an enzyme.
Oh, it is?
Yeah. I'm not 100%. We can look it up and have that answer next week. But why don't you guys all do that? Go look at what the ingredients for Ridex is. Is it a live bacteria, or is it an enzyme? And ask that question and have the answer, because you want to know. And I tell you, the enzymes, they do work, but they reform. You know, they work for a moment and then they reform. They know Ridex because of, you know, how much they pump it. But if you're there on site, you're not going to go recommend Riddex when you have BioChoice on your van. And this is more of a commercial grade product. If you want, you should do a little bit of research on BioChoice and see what they have done, with environmental, cleanup and, the design of it. It's pretty impressive. We won't get into it, all of that, but do a little research on the BioChoice. It is truly a great product.
I'll go ahead and send out a link to you guys by the end of the day. There are a lot of really good sources to provide you with information regarding Bio1 itself as a product, especially as our product. And just to, Riddex, the reason why people know that is mostly because it's moved through a lot of retail outlets, different locations. So, people see those types of things, and it's probably even got a lot more market penetration through marketing. But again, ours is a 100% live bacteria, which is far safer for the environment. Number one, far safer for people's use and consumption. There's a lot of chemicals in a lot of other products because let's just say their shelf life isn't as great. And again, enzymes are commonly used in other products because their bacteria isn't as good. So they need enzymes to break down the solids and wastes so that those bacteria can eventually consume them. So there's a lot of advantages towards Bio1 and BioChoice. They just don't move things through the retail market area historically. So
Sam said it's an enzyme. Sam, how do you know that? So Uncle Google told us it's an enzyme. We trust Uncle Google.
All right,
There's
guys.
Josh, I jumped in. I wanted to add one thing to today's meeting.
Okay.
Last week I was at the shop on Maui, well, both shops, but on Maui, when I came back, I saw David Kondo out there with his snakes out, absolutely thoroughly cleaning them with deodorant, with Lysol kind of setup. I know, high pressure water. And, I just wanted to say, that was absolutely incredible to see. I mean, you guys are snake and drains, and I have no idea why you wouldn't keep your snakes clean in the trucks, because they're in there with you. And, and it's a real sign of, to me, Dave, I really wanted to compliment you on that in front of everybody here. I was absolutely thoroughly impressed with that order of cleanliness and what you've got to work with. And that means it perpetuates all the way back to inside the house and everywhere else. So very impressive to see. I don't see it all the time. And it's a hell of a habit to keep those snakes clean, because why you want to pack that stuff around with you? And then, and then in addition to that, when you're cleaning these drains, if you're running hot water and you're doing what you can, when you keep that snake in the drain, the thing comes out cleaner, doesn't make as much mess either. But that was very, very impressive, David. I wanted to compliment you.
Yeah, David is at the mall. He's doing a maintenance there since 6 o'clock. So he did text me that he was gonna miss today, but we will let him know.
Wash his snake when he's done.
Yeah. Yeah. And for those of you who don't know David, he's only been with us for maybe like 5 months, maybe.
Oh, July is coming up on a year.
Oh, he's coming up in a year already.
Man, has he done a lot in a year's time.
Yeah, and he was put in the field, I think March. He was put on his own, and so yeah, he's our drain tech here. But yes, we are at 8 o'clock. Thank you everybody for being here today and all the participation. Ken, the knowledge, Connie, and Steve, thank you for being here today. It's always good to have that extra knowledge that the book don't have, huh? But we'll see you guys Thursday. See you guys Thursday for Connie's meeting. Thank you.
Bye, everybody.
Thank you.
All right. Have a good day.
thank
You
you.
guys too.
Bye.
Thanks, Josh.
Thank you.